Hello everyone, this is Nifty255, and welcome back to my KSP modding tutorial series, Volume 1, Custom Parts, Episode 4, Fields, Events, and Actions. In today's episode, we will discuss the process of making modules capable of retrieving settings from the part configs and saving to and loading from the persistence file. We will also discuss how to allow the player to interact with our module both through the part's right-click menu, or context menu, and through action groups. Keep in mind that this tutorial assumes that you have watched the previous and have a fair knowledge of programming in the C# language. It is also recommended that you have a fair knowledge of Unity 3D. If you remember, I discussed in the last episode a few things we had gained access to by inheriting the part module class. 3 of those things were fields, events, and actions. These are what C# calls attributes. Basically, you can attach attributes to variables, functions, and even classes in order to provide additional data about those objects. The KSPFIELD attribute can attach to variables and allows them to be automatically loaded from the part's config file, and can even allow you to save and load it from a game save file if you choose. The KSPEVENT attribute can be attached to functions and allows the player to activate it by right-clicking on an attached part and clicking the button Use Set. This is how science experiments work. The KSPACTION attribute can also be attached to functions and allows the player to activate it by assigning your module to an action group and using it during flight. This is how plenty of parts work, from lights to landing gear, not to mention you can assign engines to your action groups as well. So before we get into the details with each one, let's go over how to define an attribute. Firstly, most attributes can only be attached to certain code. For example, the KSPFIELD attribute can only be attached to variables, or what C# calls fields. The KSPEVENT and KSPACTION attributes can only be attached to functions. That said, you have to know what the attribute can be used for before you can use it. So in this example, I have defined a variable called alarm threshold. If you remember, we used this exact variable in our module to test the temperatures of each part. Just above this variable, add a new line and begin it with an opening square bracket. Next, add the KSPFIELD attribute and end it with a closing square bracket. With just this line, the game will now read this from the part's config and use the default assigned number if it isn't found. Because of the way this works, it is recommended that every variable you attach the field attribute to should also have a default value assigned. So our variable loads from the part config, but what if we also want to display it to the player, or even allow him or her to change it? We can do that very easily. In a way, attributes are just like functions, in that they can take parameters. But unlike functions, attributes don't need emptied parentheses if no parameters are supplied. Also, you don't need to supply all of the accepted parameters. You can provide all, some, or none. In order to add parameters, it's as simple as adding parentheses just before the closing bracket. So let's go over what parameters there are to add. The first is called GUI active. If this is true, then this field will be visible in the part's context menu while in flight, but only if the ship the part is attached to is the one you are controlling. In other words, you can't see the field if you are controlling another ship close by, or even on EVA. You can only see it when you are controlling the same ship. The second is called GUI active editor. If this is true, then this field will be visible in the context menu, but only while you are editing the ship. The next is called GUI name. This string parameter is what the field will appear as in the context menu. In our example, we would set this to temperature threshold or something similar, but our string can't be too long or the game will cut some of it out. It may be better to use alarm threshold or temp threshold since it is shorter. Here is how our value would appear in the game with this string. As you can see, we don't need to worry about the colon, but we do need to worry about the format of our field. That is for the next parameter. It is called GUI format. This string parameter is what can give our decimal field the appearance of being a true percentage, including the percent symbol. For this particular format, we would use the string P0. The P states that the number should be a percentage, and the 0 states that there should be no decimals, only a whole number. This string parameter takes all of the same strings as the toString function, which can be found on most, if not all, variable types out there, including int, float, and even bool. For convenience, I have included a link to Microsoft's developer site in the description, which has more information on string formatting. The next parameter is called GUI units. This is another string parameter that adds the provided string to the end of the number. In our case, we don't need it, but it can be more useful if we were trying to display a measurement of velocity, length, liquid volume, weight, or anything else that has a unit. If we were trying to display a speed of 100 meters per second, we could set this parameter to m/s, and our speed in-game would display the number with our unit attached to the end. The next is called category. Unfortunately, there is no known use for this parameter as of 0.23.5, but I felt it best to include it so that it was at least made aware of. The last parameter is called isPersistent. This, when set to true, will save your field with the ship to the persistence file and load it, replacing the default if found. This is only relevant once your ship is in flight. If we needed to save the condition of the module and load it again when we went back to it, setting this parameter will do the trick. Now, let's use these parameters to modify our heat alarm module. Open up your version of Visual C# and open the module. Now, let's add the attribute. We're going to set GUI active to true, GUI active editor to true, GUI name to temp threshold, GUI format to P0, and isPersistent to true. Now that the field is visible, we also need to make it editable. To do that, we need another attribute I haven't mentioned yet. It's called UI float range. This attribute turns the field into an editable bar while in the editor. Add this attribute just like KSPFIELD and use these parameters. Min value equals 0.7, max value equals 1, and step increment to 0.01. This is all we need to do. Now the player can edit the threshold at which our alarm sounds, but we keep them from lowering it to something ridiculous like 10%. Now that fields have been covered, let's move on to events. As I said earlier, events are attached to functions that you want the player to activate. This is useful for turning things off and on, similar to lights and engines. Let's add a Boolean value called alarmOn to our module and set its default to true. If this is false, our alarm will not activate once the temperature threshold is reached, but we set the default to true, so the alarm will be on by default. Next, we need to add this new value to an if statement in the onUpdate function. Add it here, where it checks if the alarm should sound and if the audio isn't already playing. It should now be if alarm is on, and alarm should sound, and alarm isn't already playing. Note that this new variable doesn't save if we were to switch vessels. I'll leave the exercise of adding a field attribute to it up to you. Next, we need to add the function which will toggle the new variable. Add a new function called toggleAlarm and add the following code. This basically switches the variable to true if it is false, or false if it is true. Now we can add the KSPEVENT attribute to it. This attribute, like the field attribute, has some of its own optional parameters. Let's look at these now. The first four, called GUI active editor, GUI name, and category, are just like those in the field attribute. They perform the same functions in the event attribute. The category parameter currently has no known use in this attribute as well. The next three are called GUI icon, name, and isDefault. These parameters also currently have no known use. The eighth, called GUI active unfocused, is basically the exact opposite of GUI active. If this is true, then this event will be visible, but only if the vessel you are controlling is not the same vessel this module's part is attached to. The ninth is called active. This is basically a master switch for GUI active editor, and GUI active unfocused. If this is true, then those three will behave normally, but if it is false, then the event will not be visible anywhere. The next parameter is called unfocused range. This floating point parameter determines how close, in meters, you have to be to the part you're clicking on to see the event. If you've ever tried to dock and clicked on the target docking port, you would not have seen the Set as Target event if you were too far away, even if your click was accurate. This parameter defines that cutoff distance. The last is called external to EVA only. If active and GUI active unfocused are true, and this is also true, then this event will only be visible if the vessel you are controlling is a Kerbal on EVA. This is useful if you want to have things to do that only kernels can do. Now that we've learned about events, let's add one just above our new toggle function. For this event, we'll set active to true, GUI active to true, GUI active editor to true, and GUI name to turn alarm off. Now, I'm going to show you how to modify field, event, and action attributes in the code. Add one more line inside our toggle function and add this code. As you can see by this line, we are accessing an inherited list called events. This list holds all events this module has created. By accessing this list, we can search for an event by the name of the function it is attached to. The same holds true for fields in the fields list, except you'll be using the name of the variable the field attribute is attached to. Using this, you can change any parameter it contains, including whether or not it is active, what its GUI name is, or even change how and when it can be viewed. Our code changes the GUI name based on whether the alarm was just turned on or off. If it is now on, it changes to turn alarm off, and if it is now off, it changes to turn alarm on. Using similar code, it is possible to modify any field, event, or action you have access to, including those of other modules or even other parts, although there is mostly no reason to modify actions. You'll find out why in a second. At this point, the alarm should now be able to turn on and off, based on the player's input in the context menu. If you want to test it, be sure to rebuild, recopy, and relaunch the game. The last attribute we will cover is the KSPACTION attribute. But before we can use it, we need another function. Let's call it toggle action. Inside this function, we are going to simply call the toggle alarm function, since our action group should do the same thing as our event. Next, let's look at the parameters an action attribute uses. The first parameter is GUI name. We've seen this before and it acts mostly the same. The only difference is where you see it. An action's GUI name is only seen in the editor when you're assigning action groups. The next and last is the parameter called action group. This, if assigned, causes our action to fall under that action group as a default when the module is created. Of course, the player can change it, but it will use whatever you assign here as a default. This is almost never used, since most modules with actions should be unassigned by default to prevent accidental activation, but it can come in good use in very special cases. Take one of the newest parts to come in 0.23.5, the launch escape system. This part should be assigned by default to the abort group. This removes the need for the player to worry about it. So let's add that attribute, and we'll only use the GUI name parameter. We'll call it toggle alarm. That's it. Our module's functionality is vastly improved. We've added persistence, or the ability to save and load itself. We've allowed the player to change the threshold in the editor. And we've allowed the player to turn our alarm on and off through the use of the context menu or through action groups. We've even learned how to modify any of these three attributes in code. Be sure that you rebuild, recopy, and relaunch if you want to test it again. This concludes today's tutorial. Thank you all very much for watching my tutorial series and providing feedback. And if you have any questions, comments, or concerns, feel absolutely free to post them in the comments section below. Also, if you like this series and want to see more, please do leave a like and click that subscribe button to see when the next episode comes out. But until then, this has been Nifty 255.